Hello, Tech House viewers. Welcome to this video on the science of astrobiology, where we will explore the possibility of life beyond Earth. For centuries, humans have looked up at the stars and wondered if we are alone in the universe. Astrobiology is a field of science that seeks to answer this age-old question by studying the conditions necessary for life and searching for signs of it beyond our planet. Join us as we delve into the fascinating world of astrobiology, examining the latest research, methods, and technologies used to explore the cosmos in search of extraterrestrial life. Are we alone in the universe, or is life thriving beyond our planet? Let's find out. What is astrobiology and why is it important? Astrobiology is a relatively new and exciting field of science that seeks to understand the origin, evolution, distribution, and future of life in the universe. It is an interdisciplinary field that combines elements of astronomy, biology, geology, chemistry, and physics to study the conditions necessary for life and the potential habitability of other planets and moons. The origins of astrobiology can be traced back to the work of scientists like Giordano Bruno and Johannes Kepler, who suggested that other planets might be home to life. However, it wasn't until the second half of the 20th century that astrobiology began to emerge as a formal scientific discipline. This was largely due to advances in technology that allowed scientists to explore the cosmos in new and exciting ways, including the launch of the first artificial satellites and the development of powerful telescopes and spacecraft. Astrobiology is important because it addresses one of the most fundamental questions in science: are we alone in the universe? By studying the limits and diversity of life on Earth and the possibility of life beyond our planet, astrobiology helps us better understand our place in the universe and the potential for life to exist elsewhere. The insights gained from astrobiology research also have practical applications, including the development of technologies for space exploration, the understanding of Earth's own habitability, and the identification of potential biosignatures that could be used to detect life beyond our planet. One of the key objectives of astrobiology is to identify the conditions necessary for life to emerge and evolve. To do this, astrobiologists study the history of life on Earth, as well as the physical and chemical environments that support life. They also explore the potential for life on other planets and moons within our solar system, as well as exoplanets in other star systems. Another important aspect of astrobiology is the search for biosignatures. Biosignatures are any measurable indicators that suggest the presence of life, such as the presence of certain gases or the detection of complex organic molecules. The search for biosignatures is a key focus of astrobiology research, as it could provide conclusive evidence of extraterrestrial life. Astrobiology research also has important implications for the future of space exploration. By studying the habitability of other planets and moons, astrobiologists can identify potential targets for future missions and develop strategies for exploring and studying these targets. They can also develop new technologies and methods for exploring the cosmos, including the development of robotic spacecraft and advanced remote sensing techniques. In summary, astrobiology is a fascinating and important field of science that seeks to explore the possibility of life beyond Earth. By studying the conditions necessary for life and the potential habitability of other planets and moons, astrobiologists help us better understand our place in the universe and the potential for life to exist elsewhere. The insights gained from astrobiology research also have practical applications, including the development of technologies for space exploration and the identification of potential biosignatures that could be used to detect life beyond our planet. The search for life beyond Earth, methods and approaches. The search for life beyond Earth is one of the most exciting and challenging scientific endeavors of our time. Astrobiologists use a range of methods and approaches to investigate the possibility of life beyond our planet, including the exploration of our own solar system and the study of exoplanets in other star systems. One approach to the search for life beyond Earth is the study of extreme environments on our own planet. By studying organisms that thrive in extreme conditions, such as hot springs, deep-sea hydrothermal vents, and polar regions, scientists can gain insights into the limits and diversity of life on Earth. This information can then be used to inform the search for life on other planets and moons that may have similar extreme environments. For example, the The discovery of microbial life thriving in the extreme conditions of hydrothermal vents on the ocean floor has led scientists to consider the possibility of life existing in similar conditions on other ocean worlds in our solar system, such as Europa and Enceladus. Another approach to the search for life beyond Earth is the study of planetary and atmospheric conditions that could support life. This includes the study of the habitable zone around stars, where temperatures are just right for liquid water to exist, a key ingredient for life as we know it. Scientists also study the composition of exoplanet atmospheres to look for biosignatures, or measurable signs that life might be present. For example, the discovery of phosphine gas in the atmosphere of Venus has led to speculation that it might be produced by life in the planet's clouds. The exploration of our own solar system is another important method for the search for life beyond Earth. Robotic spacecraft have been sent to explore the surface and subsurface of planets and moons in our solar system, such as Mars, Europa, and Enceladus. These missions have revealed evidence of past and present conditions that could potentially support life, such as the presence of liquid water on Mars and the subsurface oceans of Europa and Enceladus. NASA's Perseverance rover, currently exploring Mars, is designed to search for signs of past microbial life on the red planet. Finally, the search for intelligent extraterrestrial life is another important aspect of astrobiology research. This includes the search for radio signals or other forms of communication from other civilizations, as well as the study of potential technosignatures, or signs of technology that may be present on other planets or moons. For example, the discovery of an unusual star system called Tabby's star, which exhibits irregular fluctuations in brightness, led to speculation that it could be caused by a Dyson sphere, a hypothetical megastructure built by an advanced civilization to harness the energy of its star. In summary, the search for life beyond Earth is a complex and multifaceted endeavor that requires a range of methods and approaches. By studying extreme environments, habitable zones, exoplanet atmospheres, and exploring our own solar system, astrobiologists are working to uncover the secrets of the universe and the potential for life beyond our planet. Whether we discover microbial life on another world, evidence of past life, or even evidence of intelligent civilizations, the search for life beyond Earth promises to be one of the most important scientific pursuits of our time. The habitability of other planets, factors to consider. When it comes to the search for life beyond Earth, one of the most important factors to consider is the habitability of other planets. Habitable planets are those that have the necessary conditions to support life, such as the right temperature, the presence of water, and the right mix of atmospheric gases. However, not all planets are created equal when it comes to habitability, and astrobiologists must consider a range of factors when searching for potentially habitable worlds. One of the most important factors in the habitability of other planets is the distance from their star. Planets that are too close to their star may be too hot for life, while planets that are too far away may be too cold. The habitable zone, also known as the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist. Planets within this zone are considered to have the greatest potential for habitability. However, the habitable zone is not the only factor to consider, as other factors such as the planet's atmosphere and geology can also impact habitability. Another important factor in the habitability of other planets is the presence of water. Water is essential for life as we know it, and astrobiologists search for signs of liquid water on other planets and moons. The presence of water can indicate that a planet has the potential to support life, as it provides a solvent for essential biochemical reactions and can act as a medium for transporting nutrients and waste. However, the presence of water alone does not guarantee habitability, as other factors such as temperature and atmospheric composition also play a role. The composition of a planet's atmosphere is another important factor in its habitability. The right mix of atmospheric gases is necessary for life to exist, as it provides the necessary components for respiration and photosynthesis. For example, Earth's atmosphere is composed of 78% nitrogen, 21% oxygen, and trace amounts of other gases, which provides a hospitable environment for life as we know it. However, the specific atmospheric composition required for life to exist may vary depending on the type of life and the environmental conditions. The presence of a magnetic field is also an important factor in the habitability of other planets. A planet's magnetic field helps to protect its atmosphere from being stripped away by the solar wind, which can make it difficult for life to survive. Earth's magnetic field, for example, helps to protect us from harmful cosmic radiation. However, not all habitable planets may have a strong magnetic field, and other factors such as atmospheric composition can also impact the planet's ability to retain its atmosphere. Finally, the geological and environmental history of a planet is also an important factor in its habitability. Planets with a stable geological history and a relatively stable climate over long periods of time are more likely to have the conditions necessary for life to emerge and evolve. For example, Mars is believed to have had a more hospitable environment in its early history, with liquid water on its surface and a thicker atmosphere, but its unstable climate over time may have made it difficult for life to persist. In summary, the habitability of other planets is a complex and multifaceted topic that requires consideration of a range of factors. By studying the distance from a planet's star, the presence of water, the composition of its atmosphere, the presence of a magnetic field, and the planet's geological and environmental history, astrobiologists can better understand the potential habitability of other worlds. Understanding the habitability of other planets is essential for the search for life beyond Earth, as it helps us to identify the most promising targets for exploration and the best methods for detecting signs of extraterrestrial life. By considering a range of factors, astrobiologists can narrow down the search for habitable planets and identify the best candidates for future exploration. One important aspect of the search for habitable planets is the study of exoplanets, or planets orbiting other stars. Over the past few decades, advances in technology have enabled astronomers to detect and study exoplanets in unprecedented detail. By analyzing the light from distant stars, astronomers can determine the properties of exoplanets, such as their size, mass, and orbital characteristics. This information can be used to infer the presence of habitable conditions, such as the presence of liquid water or the right atmospheric composition. However, the study of exoplanets is still in its early stages, and much more research is needed to determine the habitability of these worlds. The presence of a potentially habitable planet does not necessarily mean that life is present, and more data is needed to confirm the presence of habitable conditions and detect signs of life. The search for habitable planets also involves the exploration of our own solar system. Our solar system contains several potentially habitable worlds, including Mars, Europa, and Enceladus. Robotic spacecraft have been sent to these worlds to search for signs of past or present habitable conditions, such as the presence of liquid water or organic compounds. These missions have revealed evidence of past and present conditions that could potentially support life, such as the presence of liquid water on Mars and the subsurface oceans of Europa and Enceladus. In addition to studying the conditions necessary for life to exist, astrobiologists also study the potential forms of life that could exist beyond Earth. Life as we know it is based on carbon and water, but other forms of life based on different chemical elements or solvents could exist in different environments. For example, some astrobiologists have proposed the possibility of life based on methane, ammonia, or even liquid hydrogen in the extreme environments of gas giants like Jupiter. In conclusion, the search for habitable planets is a complex and multifaceted topic that requires consideration of a range of factors. By studying the distance from a planet's star, the presence of water, the composition of its atmosphere, the presence of a magnetic field, and the planet's geological and environmental history, astrobiologists can better understand the potential habitability of other worlds. Whether searching for habitable exoplanets or exploring our own solar system, the study of habitable conditions is essential for the search for life beyond Earth. The ethics of searching for extraterrestrial life. The search for extraterrestrial life raises a number of ethical questions and considerations that must be addressed by scientists and society at large. While the discovery of extraterrestrial life would be one of the most profound scientific discoveries of our time, it also has the potential to challenge our fundamental beliefs and values about ourselves and our place in the universe. One of the primary ethical considerations surrounding the search for extraterrestrial life is the potential impact on human society and culture. The discovery of extraterrestrial life could have profound implications for our understanding of our place in the universe, our religious beliefs, and our sense of identity. Some people may find the idea of life beyond Earth to be comforting, while others may find it unsettling or even threatening. Another ethical consideration is the potential impact of our search for extraterrestrial life on other intelligent civilizations. Some scientists have argued that our search for extraterrestrial life could be interpreted as a form of aggression by other civilizations, or that we could inadvertently harm or disrupt other civilizations through our activities. For example, the broadcasting of radio signals into space could inadvertently reveal our presence to other civilizations, potentially leading to unintended consequences. The potential impact of our search for extraterrestrial life on other forms of life is also an important ethical consideration. If we were to discover extraterrestrial life, we would need to carefully consider how our activities could impact these life forms, and how we could protect them from harm. For example, we would need to ensure that our exploration of other planets and moons does not inadvertently contaminate these environments with Earth-based microbes, which could pose a threat to indigenous life forms. Finally, the search for extraterrestrial life also raises important ethical questions about resource allocation and funding priorities. The search for extraterrestrial life is a complex and expensive endeavor, and some people may argue that the resources and funding devoted to this search could be better spent on other pressing issues, such as climate change or poverty reduction. In conclusion, the search for extraterrestrial life raises a range of ethical considerations that must be addressed by scientists and society at large. While the discovery of extraterrestrial life would be a profound scientific achievement, we must carefully consider the potential impact of our search on human society, other civilizations, and other forms of life. By addressing these ethical considerations, we can ensure that our search for extraterrestrial life is conducted in a responsible and respectful manner. The future of astrobiology, advancements and challenges. Astrobiology is a rapidly evolving field that has made significant progress in recent years, thanks to advances in technology and our understanding of the conditions necessary for life to exist. However, there are still many challenges and unanswered questions that astrobiologists must face in the coming years. One of the most promising areas of research in astrobiology is the search for habitable exoplanets. Over the past few decades, advances in technology have enabled astronomers to detect and study exoplanets in unprecedented detail. These discoveries have revealed a wide range of planetary systems, from hot, rocky worlds to massive gas giants. By studying the properties of these exoplanets, astrobiologists can better understand the potential habitability of other worlds. One of the key challenges in the search for habitable exoplanets is the development of new technologies that can detect signs of life beyond Earth. Current methods for detecting life, such as analyzing atmospheric composition or searching for biosignatures, are still in their early stages and require further refinement. In the coming years, astrobiologists will need to develop new techniques and instruments that can better detect signs of life on other planets. Another important area of research in astrobiology is the study of extreme environments on Earth, which can serve as analogs for potential habitats on other worlds. These environments, such as hydrothermal vents and Antarctic ice, can provide insights into the potential forms of life that could exist beyond Earth. By studying these environments, astrobiologists can better understand the conditions necessary for life to exist and evolve in extreme environments. The study of the origins of life is another important area of research in astrobiology. Scientists are still working to unravel the mystery of how life emerged on Earth, and to determine whether life could emerge on other planets under different conditions. By studying the chemistry of early Earth and the potential habitable conditions of other planets, astrobiologists can gain insights into the origins and evolution of life. Finally, one of the biggest challenges facing astrobiology is the development of new missions and technologies for exploring other planets and moons. Robotic missions to Mars and other solar system bodies have revealed evidence of past and present habitable conditions, but more ambitious missions will be needed to search for signs of extraterrestrial life. These missions will require new technologies and instruments that can better detect signs of life and explore the extreme environments of other worlds. In conclusion, the future of astrobiology is both exciting and challenging. Advances in technology and our understanding of the conditions necessary for life to exist are opening up new possibilities for the search for life beyond Earth. However, there are still many unanswered questions and challenges that must be addressed in the coming years. By continuing to push the boundaries of science and technology, astrobiologists can unlock the mysteries of the universe and explore the potential for life beyond our own planet. The significance of astrobiology for humanity. Astrobiology is a field of study that explores the potential for life beyond Earth and seeks to answer some of the most fundamental questions about our place in the universe. While the search for extraterrestrial life may seem like an abstract and esoteric pursuit, it has significant implications for humanity and our understanding of our place in the cosmos. One of the most significant implications of astrobiology for humanity is the potential for the discovery of extraterrestrial life. The discovery of life beyond Earth would be one of the most profound scientific discoveries of all time, and could have profound implications for our understanding of the universe and our place within it. It would force us to rethink our place in the cosmos and to reconsider our notions of what it means to be alive. Another important implication of astrobiology for humanity is the potential for the discovery of habitable worlds beyond Earth. The search for habitable exoplanets has already revealed a wide range of planetary systems, many of which could potentially harbor life. These discoveries have the potential to inspire new generations of scientists and engineers, and to catalyze new technologies and industries focused on space exploration and habitation. The study of astrobiology also has important implications for our understanding of the origins and evolution of life on Earth. By studying the conditions necessary for life to exist and evolve, astrobiologists can gain insights into the origins of life on our own planet, and the potential for life to emerge and evolve in other environments. This knowledge has the potential to inform our understanding of the history of life on Earth, and to shed light on the potential for life to exist elsewhere in the universe. Finally, astrobiology has important implications for our understanding of the future of humanity. As we face growing environmental challenges and the potential for global catastrophes, the study of astrobiology can provide insights into the potential for life to survive and thrive in extreme environments. By studying the conditions necessary for life to exist and evolve, astrobiologists can help inform our efforts to ensure the long-term survival and well-being of humanity. In conclusion, the study of astrobiology has significant implications for humanity and our understanding of the universe. The search for extraterrestrial life and habitable worlds has the potential to inspire new generations of scientists and engineers, and to catalyze new technologies and industries focused on space exploration and habitation. The study of astrobiology can also provide insights into the origins and evolution of life on Earth, and into the potential for life to survive and thrive in extreme environments. By continuing to push the boundaries of science and technology, astrobiologists can help us unlock the mysteries of the universe and explore the potential for life beyond our own planet. Astrobiology and the search for answers to life's biggest questions. Astrobiology is a field of study that seeks to answer some of the biggest questions about life and the universe. From the origins of life on Earth to the potential for life beyond our planet, astrobiology is a multidisciplinary field that draws on a range of scientific disciplines to explore the mysteries of the cosmos. One of the biggest questions that astrobiology seeks to answer is the origins of life on Earth. Despite decades of research, the exact mechanisms by which life emerged from non-living matter remain a mystery. Astrobiologists study the conditions on early Earth and the chemical reactions that could have led to the formation of the first living organisms, in order to shed light on this fundamental question. Another important question that astrobiology seeks to answer is whether life exists beyond Earth. The discovery of extraterrestrial life would be one of the most profound scientific discoveries of all time, and could have profound implications for our understanding of the universe and our place within it. Astrobiologists search for signs of life beyond Earth by studying the conditions necessary for life to exist, such as the presence of liquid water and the right atmospheric composition. The search for life beyond Earth also raises important questions about the potential forms that extraterrestrial life could take. Life as we know it is based on carbon and water, but other forms of life based on different chemical elements or solvents could exist in different environments. Astrobiologists study the potential forms of life that could exist beyond Earth, and the conditions necessary for their survival and evolution. In addition to answering questions about the origins and potential forms of life, astrobiology also seeks to answer some of the biggest questions about the universe itself. For example, astrobiologists study the potential for life to exist in extreme environments, such as the subsurface oceans of icy moons, or in the harsh conditions of space. By studying the potential for life to exist in these environments, astrobiologists can gain insights into the fundamental principles that govern the universe. In conclusion, Astrobiology is a field of study that seeks to answer some of the biggest questions about life and the universe. From the origins of life on Earth to the potential for life beyond our planet, astrobiology draws on a range of scientific disciplines to explore the mysteries of the cosmos. By continuing to push the boundaries of science and technology, astrobiologists can help us unlock the secrets of the universe and answer some of the most profound questions about life and our place in the cosmos. Astrobiology and the implications for future space exploration. Astrobiology is a field of study that has significant implications for the future of space exploration. By studying the conditions necessary for life to exist and the potential for life beyond Earth, astrobiologists can inform our efforts to explore and colonize other planets and moons. One of the key implications of astrobiology for future space exploration is the search for habitable worlds beyond Earth. The discovery of habitable exoplanets could provide new targets for future missions and inspire new technologies and industries focused on space exploration and habitation. In addition, the study of habitable conditions on other planets and moons can provide insights into how we can create habitable environments for humans in space. Another important implication of astrobiology for future space exploration is the potential for the discovery of extraterrestrial life. The discovery of life beyond Earth would be a profound scientific achievement and could have significant implications for our understanding of the universe and our place within it. The search for extraterrestrial life can inform our efforts to explore other planets and moons and help us to understand how life can emerge and evolve in different environments. The study of astrobiology can also inform our efforts to protect other planets and moons from contamination by Earth-based organisms. As we explore other worlds, we must be careful not to inadvertently contaminate these environments with microbes from Earth, which could pose a threat to indigenous life forms. By studying the potential for contamination and developing protocols to prevent it, astrobiologists can help us to explore other worlds in a responsible and ethical manner. Finally, the study of astrobiology can provide insights into how we can sustain life in space for extended periods of time. By studying the conditions necessary for life to exist in extreme environments, astrobiologists can inform our efforts to create self-sustaining habitats for humans in space. This knowledge can also inform our efforts to address some of the pressing environmental challenges facing our planet, such as climate change and resource depletion. In conclusion, astrobiology is a field of study that has significant implications for the future of space exploration. By studying the conditions necessary for life to exist and the potential for life beyond Earth, astrobiologists can inform our efforts to explore and colonize other planets and moons, and to create self-sustaining habitats for humans in space. By continuing to push the boundaries of science and technology, astrobiologists can help us to unlock the mysteries of the universe and to chart a course for a sustainable future in space. Astrobiology and the potential impact on society. Astrobiology is a field of study that has the potential to have a significant impact on society, both in terms of our scientific understanding of the universe and in terms of our cultural and societal values. As we explore the potential for life beyond Earth, we must also consider the ethical and social implications of these discoveries. One of the most significant impacts of astrobiology on society is the potential for the discovery of extraterrestrial life. The discovery of life beyond Earth would be one of the most profound scientific discoveries of all time, and could have significant implications for our understanding of the universe and our place within it. It could also challenge our fundamental beliefs and values about ourselves and our place in the cosmos. The potential impact on society also extends to the search for habitable exoplanets. The discovery of habitable worlds beyond Earth could provide new targets for future missions, and inspire new technologies and industries focused on space exploration and habitation. This could have significant economic and social implications for society, as well as for our understanding of our place in the universe. Another important impact of astrobiology on society is the potential for the development of new technologies and industries. The search for extraterrestrial life and habitable worlds has driven advances in technology, such as new methods for detecting biosignatures or for exploring the extreme environments of other planets and moons. These advances could have significant benefits for society, both in terms of economic growth and in terms of improving our quality of life. Finally, the study of astrobiology also raises important ethical questions and considerations. As we explore the potential for life beyond Earth, we must carefully consider the potential impact of our activities on other civilizations, other forms of life, and on human society and culture. We must also consider the allocation of resources and funding priorities, and the potential unintended consequences of our activities. In conclusion, the study of astrobiology has the potential to have a significant impact on society, both in terms of our scientific understanding of the universe and in terms of our cultural and societal values. As we explore the potential for life beyond Earth, we must consider the ethical and social implications of these discoveries, and work to ensure that our activities are conducted in a responsible and respectful manner. By doing so, we can unlock the mysteries of the universe and pave the way for a better future for all. Thank you for watching this video about astrobiology. We hope you enjoyed learning about this fascinating field of study and its potential implications for our understanding of life and the universe. If you enjoyed this video, please give it a thumbs up and consider leaving a comment below to share your thoughts or questions. Don't forget to subscribe to our channel for more videos about science and technology. By subscribing, you'll be notified of our latest content and will be joining a community of like-minded individuals who share a passion for exploring the mysteries of the universe. Thank you again for watching, and we'll see you in the next video.